Hello again. We're going to be solving inequalities this time, and by solving inequalities, it's similar to solving equations, and they're going to be one-step inequalities. There is a couple things that you have to keep in mind when solving inequalities that's slightly different, but other than that, it's really not that bad. And I'm going to draw a number line for most of these, if not all of them, just to show you what's really going on too. So the first one reads x minus 5 is greater than 2.5. So you want to get the x by itself. Actually, you want to get the variable by itself. So you add 5 to both sides, because if you wanted to use a c or a d, you could do that too. And you get x is greater than 7.5. Basically, what that means is this. Any number bigger than 7.5 that you substitute in will work. 8 is bigger than 7.5. So 8 minus 5 is 3. 3 is greater than 2.5. But any number smaller than 7.5, let's say 7, will not work for this problem. 7 minus 5 is 2. 2 is not greater than 2.5. That's essentially what we're doing here. But when it comes to inequalities, you also have to put them either on a number line or a Cartesian plane, depending what the problem's asking for. All of these are just number line problems. I'm going to show you something cute too, actually, that I learned from another instructor when I first started teaching, because I always had my own way of teaching, and you learn things when you learn from different teachers. So I particularly like this way, and I teach it when I do it this way too. So I'm going to create a number line, and I tell my students, you can be lazy on this number line if you want to. And here's what I mean. There's 7.5. Bam! Done. You don't need to really create any other numbers. You just need to give me a number line that conveys the message. Now, if it's greater than, or if it's less than, it's an open circle. But if it has a line underneath it, greater than or equal, or less than or equal, it's a closed circle. So keep that in mind too. So this one's an open circle, and you have to tell me what answers are greater. And you can't possibly list out all the answers, but you can show it in a picture. A picture's worth 1,000 words. Now here's a trick my colleague showed me. If you put the variable on the left when you're solving, then just follow the way the arrow points. So if the arrow points that way, you shade that way. If the arrow is a less than and it's going that way, then you shade less than. That's pretty much it. That's one way to look at it. Another way that I used to do it was, I used to tell my students, go ahead and substitute in a number. If 9 works, then it goes this way. If 9 doesn't work, it goes the other way. But actually, I like this way. That's why I use it now. So it's telling me, go that way. Just go. Just go. So I'm just going. And that's it. I want to solve this next one, which is slightly trickier, but not really. Get the variable by itself, so subtract 4. One is greater than or equal to x. Now, when students see this, they say, well, I can't use that arrow trick, or they think the arrow goes this way. It actually doesn't. It actually goes the other way, and I'll show you why. I want you to always try to put the variable on the left-hand side. So I want you to rewrite this exactly as it is, except with the variable on the left-hand side. So x is less than or equal to 1. It's the same exact thing, except I put the variable on the left. See, the arrow is still pointing to the x, Just looks a little different, but it's more convenient this way, I assure you. Make yourself a number line. Be lazy. Here's number 1. That's all you really need. It's a closed circle because it has a line underneath it. And the arrow is saying, hey, shade to the left. Go that way. And that's it. Now, when it comes to fractions, and it's your last step, I wouldn't cross multiply. That's when you have an equals. I would use the reciprocal property. And this is actually a 1x over 4. You don't really need to pay attention to the 1, but I think it helps students. So multiply by its reciprocal. So this was 1/4 multiplied by its reciprocal, which is 4 over 1, on both sides, because what you do on one side of an inequality, you better do on the other. X is greater than 2 times 4 is 8 over 1. I don't need over 1, it's just 8. Here's my number line, open circle or closed. Open because there's no line, and the arrow saying, hey, that way. Now, it's amazing. When I review this concept with my students, I can review many concepts like fractions and division and multiplication and adding negative numbers, and students don't seem to have a good grasp. But for some reason, they always remember this. So it comes to my mind that this must be something that's incredibly drilled at lower level than high school when they get back here. But you want to solve for x here. You want to get x by itself. So you multiply by its reciprocal, which is negative 4 over 1. What you do on one side, you do on the other. X is, but when you multiply or divide by a negative, it flips the inequality. And that's what students always seem to remember for some reason. I'm not exactly sure why they remember it, but they do. It flips it over there. 2 times negative 4 is negative 8 over 1. Although I did have a student one time who said to me, you know, I buy that it flips because my teacher just tells me it flips. Can you tell me why? Can you teach me why? Sure. Open or closed? Open. And it's less than. I'll tell you exactly why it flips. If you substitute the value back into the original inequality, you'll see exactly why that is. So it's x over negative 4 is greater than 2. Come up with a value less than negative 8. Negative 12 is less. No, yeah, it is. A bigger negative number is actually less. You want to owe $8 or owe $12. Owing 8 is better than owing 12. Negative 12 is less than negative 8. So I substitute in negative 12 over negative 4, which is 3. 3 is greater than 2. But if I substitute in a value bigger than negative 8, like negative 4, one is not greater than 2. That's garbage. That's basically it. If that seems a little difficult, substitute in numbers yourself, and you'll see how it makes sense. And it really does make sense, but you have to substitute in the values. And that's how I learned. You know, my teacher told me, then I just had to try to prove him wrong when I was younger, and I didn't prove him wrong because it's true. Okay. Next one, 3 times x is greater than or equal to 15. 3 times, how do you get rid of a times? You divide. But what you do on one side of an inequality, you do on the other. So it's almost exactly like an equation, but not really. 3 divided by 3 is 1. X is greater than or equal to 5. Number line. Closed circle. Hey, let's go there. Finito. And there you go. 2 more problems. I like this challenging one right here. That's why I put it up there. You divide by negative 3 because it's negative 3 times x. Negative 3 and 3 cancel and become a 1. X is, no, it's not greater than or equal to, because anytime you multiply or divide by a negative, it flips the inequality. 15 divided by negative 3 is negative 5. There's your answer. And if you want to plot it, it's a closed circle because it's got a line underneath it, and it's that way. That marker's dead. There you go. Last one. It's a little bit difficult. Don't cross multiply. Don't do that. This is an inequality, not an equation. Use the reciprocal property. So it's negative 2 over 5. You want to get x by itself, so multiply by 5 over negative 2. But what you do on one side, you do on the other. X is, but when you're multiplying or dividing by a negative, flips the inequality. 2 times 5, maybe we'll do this, 2 over 1, because students will still mess this up. 2 over 1 times 5 over negative 2, 2 times 5 is 10. 1 times negative 2, negative 2. 10 divided by negative 2, negative 5. Now some students are going to say, don't I flip it again? No. Because you never actually completed that step. Complete the step. It's still the same. Open circle, arrow goes that way. basically it for one-step inequalities. Of course, we're going to try two-step inequalities and see how it goes. And eventually, I think we're going to start graphing inequalities on a Cartesian axis. But until that point, have a great day. Goodbye.